Okay, so Denny is going to speak on how to maintain the same level of utilities in cloud deployment and securities, reliability, and scalability. And Denny is honor and principal consultant of Denny Cherry and Associate Consulting, and have a over a decade of experience in platforms such as Microsoft Azure and SQL Server. He is also a certified master and Microsoft MVP from United States. So over to you, Denny. Yeah.
Thank you very much. Thank you everyone for coming. First of all, I want to say I wish I could be there in person. I would love to be in Singapore right now, but sadly I am not going anywhere anytime soon apparently because American travel is absolutely horrible right now and we can't go anywhere. But hey, it is what it is. We make it work.
Yeah.
So a little bit about me, like my great friend over here just said, sorry, I'm pointing at my screen and that's where his picture is on my screen. So I am Denny Cherry. I'm the owner and principal consultant for Denny Cherry and Associates Consulting, based out of San Diego, California, where it's currently 6:30 p.m. and extremely dark out because we have stupid daylight savings time here. I've worked on 8 books on Microsoft SQL Server, including that blue one there, which is my solo project, Securing SQL Server. I've written dozens of articles on various websites, including MSDN Magazine, TechNet Magazine, Tech Target, WinIT Pro. I've been a Microsoft MVP for, I believe, 14 years now. I'm a Microsoft Certified Master, and I'm a VMware V expert. So let's dive right into it. So what I want to talk about today is security in Azure, availability in Azure, and scalability in Azure. Now, that seems like it should be a fairly simple set of things to talk about, but it's actually an incredibly in-depth set of stuff to talk about. So I will get through as much as I can. I can usually get through an hour, get through all of this in an hour. If I can't, I have already posted the slides up on the SQL Saturday website. I know they're up there because I put them up there like 10 minutes ago. If you have any questions, please feel free to throw them in the Q&A, and my wonderful assistant will see them. And feel free to interrupt me just during the session, and so we can ask questions if any come up. And if there's any at the end, we'll take care of them there as well. So either put them in the Q&A or in the chat when you have them.
Sure.
I need to click on the right app to actually forward the slides. All right, so let's talk about security in Azure a little bit. So while I'm going to talk about Azure, this all basically is going to apply to AWS and GCP as well. But we're at SQL Saturday, we're talking about Microsoft technologies, so we talk about Azure. So when we move to the cloud, we have to give a lot of control over to Microsoft. How much of that control we give over all depends on where we land in the realm of cloud technologies. We can start from our on-prem environments and then we slowly work our way up. So in an on-prem environment, we control everything, obviously. We own the hardware, we own the network, we own the software, we own the whole stack. But as we now move up to the cloud, we have to start giving away more and more of this control, depending on what kind of cloud environment we want to go into. If we want to go into an infrastructure as a service or IaaS solution, which is just virtual machines running in Azure, then we're going to give Microsoft some of this control, and then we're going to keep some of this control for ourselves. So we give Microsoft the networking, the storage, the servers, and the virtualization. And we keep part of this to ourselves. So we keep the operating system, we keep the middleware, we keep the runtime. So in this case, that would be SQL Server. We keep the data, we keep the applications all to ourselves. This is the stuff we own. As we go up to PaaS, so we go from infrastructure as a service to platform as a service, or PaaS, we then give away more of this to Microsoft, and we maintain less of this control and less of the security that we have to deal with ourselves. So we give Microsoft the control and the security worries about the OS and the middleware and the runtime, And all we're then concerned about is the data and the applications. So this is one of the benefits from a security perspective of being able to move up to the cloud and move from something like IaaS up to PaaS is we have a lot less control. We also have a lot less worries because we don't have to worry about people getting into the OS of our VMs running SQL Server because we have no control over that. We have no access to those. We give that control to Microsoft and let them worry about running that part of the platform. When we go all the way over to SaaS, software as a service, that's when we give the entire application to Microsoft. We give all the data to Microsoft or whoever the SaaS provider is in this case. And we let them run with that opportunity and let them run with that and control all of that. And they worry about the security of that because they have control of the security of all those pieces. We don't have ownership of any of those pieces. All we do is send information to the application and it does what it's supposed to do. So a great example of this is SendGrid. This is a SaaS solution in Azure that's used by almost every customer in Azure to send emails out of the Azure environment through the SendGrid service. So when you send them your information, you simply basically open up port 25 or use their API, send them the information that needs to be sent out. So they're sending emails, so who it's to, who it's from, subject and email, and any attachments. They then take that information and they send it out, and they actually handle storing that data, making sure it's secure, and safely sending out that information. It all simply gets stored in their database, so we don't have any control over that or any say of how that's all going to get secured and safely stored, because we're trusting that they're going to be doing all that for us. So it's the same level of trust, or same kind of trust that we have, whether we use infrastructure as a service, platform as a service, or software as a service. It's just a matter of how much of that we're going to be giving up to them and how much we're going to retain ourselves and how much headache we're going to manage ourselves. So as we move things up to Azure, we have to think about how Microsoft takes advantage of the security within the Azure environment. So this is a nice little bullseye picture here. So we can talk a little bit about what the security looks like, both at the physical level and the infrastructure level, and then all the way down into the actual VM itself. So at the physical data center level, we've got, this is the buildings, so the actual facilities that host Azure. They've got cameras and alarms covering every, metric inch of that place, or metric inch, that makes absolutely no sense. Every square centimeter of that place, that makes more sense. They cover the entire facility. So you can't go anywhere in the facility without being on camera. We've got staffing at these facilities that are 24/7 staffed by security personnel. And they're also staffed by Microsoft personnel to actually manage the equipment. They've got barriers and fencing all around the facility, so that in the event that a large lorry, for example, were to drive into the facility to try to go through the fence, they're going to hit that fence and not be able to go any further because that fence is going to be several meters into the ground. So that when you hit that fence with something like a big lorry, that fence is just going to bend, but it's not going to break, and it's not going to allow that lorry to go further and go into the actual building. Going into the buildings as a person is going to require two-factor control. So that's not just the proxy card that Microsoft employees have. That'll actually be a hand scan and/or an iris scan as well. So just getting access to somebody's badge isn't going to be good enough. Now, on top of all that, in the event that the power was cut, so maybe there's a power outage in the area, that's not something that the Azure data center are going to be worried about. They're going to have days worth of backup power available to them so that they can just simply keep running the data center on the backup power for days and days at a time. Now, as we move from the outer ring, that's our physical building, into the next ring in, that's our infrastructure. So that's not necessarily the infrastructure that you as the customer would design, but the infrastructure that Microsoft has around their operations. So unlike Microsoft of 20 years ago, where everything was open by design back then, think Windows 95, and if you needed to log on to a Windows 95 computer that you didn't have a username and password to, you could just hit escape on the login screen and it would take you to a desktop. So a little more secure than that. So the entire process of Azure is secure by design. So everything is closed unless we need to open a specific connection. And this actually is going to be the same technique we're going to use both at the physical infrastructure level, the virtual network level, and the VM level, as we get into our actual VMs that we control. So Microsoft has an operations security center that's going to be controlling all the infrastructure and monitoring all the infrastructure to make sure that that infrastructure is nice and secure, and so that nobody is able to get into that environment that's not supposed to be in there. They have compliance certifications, and I believe they're up to 75 or 100 plus compliance certifications that they can present to you that you can then just download off of the Microsoft website. Microsoft does regular penetration testing on their infrastructure to make sure that nobody can possibly get into it. So they actually have two teams at Microsoft, a red team and a blue team. So the red team attacks the Azure infrastructure. The blue team monitors the Azure infrastructure and looks at the logs. If the red team is able to get into the infrastructure, they tell the blue team what they got into, and the blue team then figures out how to defend that environment better. They put up the next set of roadblocks, and then the red team simply attacks again. And they just keep on going through this entire process. Anytime there is a breach or a suspected breach, there's going to be forensics done on the entire environment and the entire process to find out exactly what happened and how far that person was able to get in. Now, let's go in one segment further and let's talk a little bit about the VNet. So the VNet is what is presented to you as the network that you use where you put your VMs on. So every network is going to be secured and isolated from every other network. In fact, things are so secured and isolated that if I create two VNets in my account, they cannot see each other unless I tell Azure that they are supposed to be able to see each other. So you don't need to worry about your VMs being seen by somebody else in Azure's VMs. It's simply not a problem. It's not anything you're going to ever have to worry about. We have ACLs. These are done through network security groups. So ACLs are access control lists. And these are going to be done through what are called network security groups in Azure. And this is how we control who can talk to what within Azure and what connections can be made between the servers. We can do forced tunneling. So in the event that we have to have a third-party security plan, so maybe we have a security requirement that we have to have Cisco firewalls in place, we can use forced tunneling and we can route all our traffic through those network security appliances so that we don't have to worry about any single point of egress or ingress, and you don't have to worry about connectivity to the outside world that's not going through those, because we're doing it at the Azure level, not at the virtual machine level. Now, speaking of the virtual machines, let's go ahead and look at that absolute center of the bullseye there. So our VMs can have anti-malware installed. That's either using Windows Defender, or if we want third-party anti-malware software and antivirus software, we can install that through an Azure security extension or by literally just installing the software on the machine. Everything in Azure is controlled using role-based access controls. So if any user tries to get into any VM or do anything in Azure, it's all going to be controlled through the role-based access controls, and it's all going to be logged and audited. This is extremely important. You're not doing anything in Azure without it being logged. Now, once you're on the VM, you can do stuff within the VM without it being audited and logged by Azure. But you're not doing anything at the Azure infrastructure level or at the Azure level itself. So basically, if you're using the portal or you're using the AZ PowerShell commands or the PowerShell, or the Azure CLI, it's going to be logged and audited under your account that you did something. So we all have that person that we work with that won't fess up to them actually doing stuff within the environment. We no longer have that problem. Everything we have and everything they do is going to be logged, and we can always go back and find out what happened. So we had a problem at a customer just a couple of weeks ago, where the customer suddenly was starting to get all sorts of errors, they're having all sorts of problems, and a portion of the application appeared to be down. Well, we went into the Azure portal, excuse me, and we were able to see, okay, well, the database is there, the problems all seem to go away. So we started figuring, okay, what actually happened? We started going through the logs and going through the audit trail in Azure, and we were able to find, oh, this developer had access to production, and we know this because they dropped the database from production by accident, and not from the staging environment like they were supposed to do. And then the database was restored, and then it was renamed, and then production came back up. So we could see exactly what was going on, exactly what happened. It took a little while to figure out what everything meant in the portal, what all the auditing was, but it was all there. We could figure out exactly what happened. So we could go back to our client and go, all right, here is what actually happened. Dev dropped the database, Dev restored the database, Dev renamed the database, and several hours later, the Dev then fessed up to what they had actually done. So we were able to prove exactly what happened, and that it wasn't an Azure problem. It was literally just a people problem at that point. Now, when it comes to securing your data, on top of all this, we've got data encryption. There's lots of ways to do data encryption within Azure. So we've got the .NET APIs to do data encryption. We can do client-side encryption and storing the keys in the Azure Key Vault. We've got TDE on SQL Server, where we can actually do transparent data encryption within the VMs running SQL Server. We've also got always encrypted, which we can use within SQL Server, which will then do the encryption at the application without the SQL Server having access to the keys. And that's probably our best bet going forward for any new development, is going to be to use always on to do that encryption, because it's a nice, easy way to do it, to do regular, hardcore semantic key encryption without having to use the encryption APIs within the application, and it just kind of does it automatically unless we need to make some changes. If we're using platform as a service, we've got SQL DB TDE, so that's transparent data encryption within Azure SQL DB. So that's actually on by default in every new database created within Azure SQL DB. Anything old as of a few years ago, that's going to be turned off, and not to turn it on manually, but it's a quick flip to go ahead and turn that on. We've got dynamic data masking. So if we've got applications or users logging into the database, we can actually hide data from them that they shouldn't actually be seeing. And we've got row level security as well. So we can prevent users from actually being able to see rows that they should not be being able to see. We've also got auditing and threat detection, either at the SQL Server level, if you're running platform as a service, or infrastructure as a service, or we've got auditing and threat detection at the infrastructure as a service, at the platform as a service level, where Azure will actually be able to monitor the connections on the commands that are being run against Azure SQL DB, and look for malicious kinds of commands and throw errors to those commands and throw alerts to the administrators saying that somebody's running malicious commands. At the system level, we've got BitLocker, so we can lock VMs and BitLocker VMs if we need to. And we can actually do Azure Storage Account Encryption as well on our storage accounts if we're using legacy storage accounts for our VMs, or if we're using storage accounts for non-VM purposes. So we've got a lot of clients that are using storage accounts to store actual data. And the nice thing is we can tell them, yes, those storage accounts are going to be encrypted either by a Microsoft provided security key or by a customer provided security key. And you can do the same thing with transparent data encryption, where you can bring your own key and use that key to secure the data. So even Microsoft can't read that information. Everything's got to be done through your key. There's also some third-party disk encryption options as well. Now, one of the great things that I actually absolutely love in Azure is the Azure Security Center. So what this lets you do is get some great visibility into your entire environment and see what actual problems you have within your environment and what you need to do to actually try and solve those problems. So you can quickly and easily see what problems you have in the entire environment, get visibility into those problems, and then how to remediate those problems. And a lot of the problems you can remediate straight from the Microsoft Security Center. So these are a couple of older screenshots, but I want to go ahead and zoom in on them just a little bit here. So you can see here that in this particular environment, we had some virtual machines, we had some networking issues, we had some SQL issues, and we had some application issues that the Security Center was able to know about. And when we click down into the recommendations here, we can see exactly what kind of recommendations were being made here. So we click here, we need to add a web application firewall, or a WAF, to the environment. And we can click that. It would simply give us a list of all the available WAFs that were in Azure at the time. Now, obviously, there's going to be more today because this screenshot is a little bit older. But we can see here exactly what kind of web application firewalls we needed to deploy to the environment to make the environment more secure and to get the performance, or to get the safety of the data to be where we were looking for and what we were looking for. And we can trend this data over time and see exactly what's going on within the environment and what we need to get fixed. This is an incredibly powerful tool for auditing purposes, especially. A lot of the times when I work with auditors for our clients, they go, "Hey, what are all the security problems that you see? Or what kinds of things are we going to be looking for in Azure? What can we look for?" And I can just pull this up and take a screenshot of it and send it to them and go, "Hey, according to the security portal at Microsoft, we're in the clear, or we're not in the clear. These are the things that Microsoft says we need to resolve. So these are some of the things that you can put on your audit and say, you need to go ahead and resolve this." So we've got integrated security and monitoring and policy management all in here, as well as threat detection and alerting. So when there are high-level problems, it will actually send a message out to the admins and say, "Hey, there's something we need to go ahead and try and resolve. There's something that's a new problem that's come up." So some common mistakes that I see all the time, although thankfully less now, for SQL servers. The first problem is setting up public IPs for your SQL servers. SQL servers should pretty much never be accessible from the outside world. Now, when we're talking about SQL servers here, we're talking here about infrastructure as a service. Platform as a service is obviously a totally different beast, but that being said, even with platform as a service, you probably don't need to expose your SQL server, your SQL DB, or your managed instance to the public internet. You can set both of them up to be accessible only via private endpoints. You can then connect those managed instances and SQL DBs up to your local VNet. So they're given private IP addresses on the local VNet, and then you simply connect to them via those private IPs. When VMs have a public IP, there's no firewall between the VM and the internet. So literally anybody at that point can connect up port 1433 to your SQL server. So that's obviously going to be a problem. That's how we get messages in the error logs saying people are trying to log into your server with the SA username and password. If for some godforsaken reason you did have to put a public IP address on a VM running SQL server, always configure a network security group to limit the people that can get access to that SQL server, so it's the smallest number of people as possible. Another issue I've seen that I try to resolve at every single client we talk to is not having a VPN between their on-premise and their Azure environments. So this can be done very simply with a site-to-site VPN. And this is where we literally connect your on-prem office or your existing data center to Azure via a site-to-site VPN. If for some reason we don't want to set up a site-to-site VPN, we can do person-to-site VPNs, where you literally have your users connecting to the Azure gateway by using a certificate installed on their machine, as well as some VPN software. Not my preference because it's all done through certificates and not through actual usernames and passwords, so it's harder to manage. Our third option that I end up using a lot for user access to the Azure environments is remote access servers in Azure. So what they'll do typically is spin up 2 virtual servers in Azure and tell both those servers they should go ahead and be installed with the remote access service, and they can then go ahead and let users VPN it. And sorry, my Roomba robots have kicked off and I need to stop them real fast. But I'll keep talking. So the other problem I see people do a lot is not encrypting data at rest. We always want to encrypt our data at rest because having data running at rest that we can access is kind of a problem in the cloud. So this is done through transparent data encryption, or TDE, in SQL Server, either SQL DB or traditional SQL Server inside the VM. We also have that storage encryption for any storage accounts that we do have, but we always want to make sure it's turned on. So let's talk a little bit about availability in SQL Server. So common misconceptions that I see when it comes to running VMs in Azure is, oh, it's just VMs, but running in the cloud instead of on-prem. No, not really. There's a lot of automation behind spinning up VMs in the cloud. There's also a lot of automation around the recovery of VMs in the cloud in the event that a server goes down. Also, Microsoft's got an absolutely massive data center with thousands and thousands of physical servers that you probably don't have in your existing on-prem cloud, or your on-prem cloud, your on-prem virtualization environment. So you may have 6 or 8 or even 20 or 30 Hyper-V or VMware servers on-prem. You're like, well, the cloud is a lot like that. Well, sort of, except at an absolutely massive scale. Well, you may have 20 or 30, even maybe 100 servers running your VMs, your physical hardware running VMs. The Azure data centers are going to have tens of thousands of servers per data center that are running VMs. So in the event that something were to fail, you've got a much better chance of getting hardware back up and running, getting those servers back up and running, getting VMs back up, and even services back up for the platform as a service side. Another common misconception is Microsoft is just running a bunch of Hyper-V servers in their data centers. Well, sort of. So yes, Microsoft is obviously running Hyper-V and running Windows on the hardware, but they're not running the same Hyper-V you have access to. What they are doing though is putting new features into Windows and into Hyper-V specifically for Azure, and we're getting the benefits of that. So on the SQL Server side, automatic seeding that became available in SQL Server 2016. This exists solely because Microsoft needed it to do georeplication in Azure SQL DB. This is how they seed those georeplicated servers, is they seed them through automatic seeding. So that's why it exists in SQL Server 2016, is because they needed it for Azure, so they simply built it in the product, and we got to take advantage of it as well. So another common misconception I see is, why do I need high availability in Azure when Azure's already got high availability? So why do I need to spend money building an HA environment when Azure's already doing that for me? Well, first problem you're going to see is your SLAs are going to be way lower without HA than with. So as soon as you start putting high availability in place within your VM environment, then you're going to start getting higher SLAs for your environment because you've now got that sort of HA in place. The other thing we need to worry about is the fact that hardware does fail. You know, it's a sad reality, but it does happen. Hardware does fail and go offline. So we do need to keep, an eye on that and keep in mind that since the hardware can fail, are we going to be okay with our services being down for a minute or two while the VM restarts, or do we need to be able to fail over faster than that? So if we've got an always-on availability group built and ready for a hardware failure, if the hardware running our primary node were to fail, failover would take 2, 3, 4, 5 seconds as opposed to 2 to 3 minutes. So this is a big difference in availability, and we need to account for that up front and before things happen. Along with that, not only do the hosts fail, but they need to be patched. And you, as the user, have no control of the patching of those environments. Now, along with HA, we have disaster recovery. Let me see if I have slides on this. I guess I do. All right, we'll talk about DR in a minute. So, from a SQL Server perspective, we have availability groups. We also in Azure have this thing called availability sets. Now, these are two different things, but they should be used together. So an availability set is where we tell Azure that we have high availability within our environment. We tell Azure how we're going to be defining this high availability within our environment. So if we've got our standard 2-tier application with a web tier and a database tier, we're going to need 2 availability sets, one for each tier of the application because we want to keep those separate. We're going to need a load balancer for each tier of that application as well, because we need to be able to route data in different places. So on the web side of things, we're going to need an external load balancer because that's where our users are going to be coming in from the outside world. On the internal availability set, where the SQL servers are, we're going to need a load balancer as well. Now, there's one exception to that rule. You won't need a load balancer, that internal load balancer, on the SQL servers if you're running the newest CU of SQL Server 2019. Microsoft has eliminated the need for the load balancer, but that's only the latest CU of SQL Server 2019. Availability sets are going to look something like this. So think of an availability set as a rack. So when you define an availability set, there's this setting called a fault domain. The fault domain is effectively the server rack. So you assign either 1, 2, or 3 fault domains within your availability group. You basically would never build one with a single fault domain. So either 2 or 3 fault domains. So in my example here, I've got 2 fault domains. So each fault domain is tied to a rack. So at the top here, let me turn on my little laser pointer here. So at the top, I'm sure I can see that. No, I can't. Why can't I see my laser pointer? Because I've got the pen selected. There we go. There's my laser pointer. So at the top here, I've got my Windows VMs running my web server. And at the bottom here, I've got my VMs running my database availability group. So I've got an availability set here for my database servers. So I've got DB1 and DB2, for example, inside a single availability set. Now, because those are in the same availability set, and because I've only got 2 VMs in that availability set, it's going to assign the first one to fault domain 1, and the second one to fault domain 2. So because they're separate fault domains, those are going to be in separate racks. Now, as I put more machines into this availability set, so say I put 2 more machines into my availability set, 2 of them will be in fault domain 1, 2 of them will be in fault domain 2, assuming I've set the availability set to only have 2 fault domains. So this lets me control where things are going to be physically in the data center, but I don't necessarily know where they're going to be. I just know that everything in availability set 1 will be in one rack and will always be separate from anything in fault domain 2. So that in the event that this rack were to fail, I will lose this VM, but I won't necessarily lose this VM. Now, each fault domain is going to have its own power, its own network, and it's all completely isolated from the other racks in the environment. So if say a rack gets unplugged by accident, you don't have to worry about anybody taking the other racks offline because they're going to be totally separate. Now, by having an availability set, you're going to be able to get an SLA of 99.95% uptime on your environment. That's what Microsoft is going to help you guarantee. So that's a pretty good uptime within the environment. Now, our options for high availability, always on availability groups. Obviously, we're going to need an internal load balancer unless we're running the newest version of SQL Server 2019. Failover clustering. Again, we're going to need internal load balancer. We're also going to need third-party software to handle our replication of our storage from one server to another. Microsoft does have some software built into Windows to do that data replication, but it's absolutely horrible and does not work in Azure at scale at all. Third-party software, highly recommended. You can get that software from SIOS Data Center, that's SIOS. So if you just go to sios.com, they can direct you to the local subsidiary to help get that software. So database mirroring is also available as well. Obviously, that's going to be a deprecated option. So what are our disaster recovery options? They're actually going to look fairly the same. Now, why do we want to focus and worry about disaster recovery? It's the cloud. We're not supposed to have to worry about disaster recovery very much or at all. Well, normally I would say that was true, except there have been 2 major outages at cloud providers this week. So 2 days ago on Wednesday, AWS had a massive outage where their US East region was down for something like 8 or 12 hours. And you could tell what companies were in it, because there was a lot of them, because you could tell which ones had a DR plan and which ones didn't. The ones that didn't were the ones scrambling. So things like Roomba vacuums all stopped working around the world on Wednesday of last week, Wednesday US time. I believe that would have been Thursday morning Singapore time. There were also things like automated cat doors, which I didn't even know were a thing, but they stopped working as well because the company that runs the service for that is only in AWS US East and apparently did not have a DR plan or wasn't willing to fail over to it. Now, I said there were 2 outages this week, so I don't want to just pick on AWS. I'll also pick on Azure. They had an outage in South Africa North, which is in Johannesburg, South Africa. So apparently, the basement of that building or that data center flooded yesterday. The postmortem just came out, and it's Friday evening U.S. time right now, and the postmortem just came out a few hours ago. And apparently part of the reason that they were down was because the basement flooded, because I'm guessing of heavy torrential rains that are coming down right now in Johannesburg. So this is why we need to worry about DR, because if you've got these sorts of problems at your provider and you need a way to fail over to another region, and if that environment is down that you're using, you're just kind of out of luck. There's not a whole lot you're going to be able to do to keep everything up and running and keep things moving. Now, let's talk a little bit about scalability in Azure. So there's a couple of different scale options, ways to scale things. So there's the old school method of scaling up, where we simply assign more and more CPU and more resources to a server. So we can scale fairly high up these days. The biggest VMs in SQL Server, the biggest VMs in Azure that I'm aware of are 412 VMs, 412 cores, and I believe 6 terabytes of RAM. And you can put about a petabyte or 2 of storage on this if you want to. So you can scale up really high, but that's not always cost effective, and that's not always a great way to go. So what we do there is simply scale, making the animation go too fast. We simply scale up and up and up, and eventually we top out. There are upper limits to how high we can scale. Those big 412 core VMs, those aren't in every Azure data center. So you might not be able to get those in the region that you happen to be running. So a better solution for the cloud is to scale out. So we start small and we simply scale sideways, and we keep scaling sideways more and more and more. So what this lets us do is effectively go as big as we want, as wide as we want. And this lets us go extremely wide. So we had one client who's a large payroll processor, one of the top 3 payroll processors here in the US. And what they have is they have an Azure SQL database for every single client that they have. So they have, last I talked to them, about 35,000 SQL databases within their environment. So every time they sign up a new client, they just spin up a new database. So each one of their Azure SQL databases is just really small. I think their average database size was like 12 megs or something like that. They have a few really big ones, but for the most part, they're all really, really small. So they just keep scaling out horizontally. They assign them all to elastic pools, so they're sharing resources across a couple hundred of those databases. And everything just kind of works like 99.9% of the time, which is pretty much what they're looking for. So when we're scaling in Azure, there's a few different ways to look at it. We can use always-on availability groups, and that will let us scale our reads out. That doesn't require using Enterprise Edition. We can use merge replication, so we can scale out our reads and writes, and use Standard Edition, but merge replication is just painful. We can use peer-to-peer replication to scale our reads and our writes out. But again, this is going to require Enterprise Edition to use peer-to-peer. We can scale our reads out using transactional replication. This can be done in Standard Edition, and we can even scale our reads to Azure SQL DB or to VMs within our environment. We can also build our own processing in-house to deliver data to various databases around the world. But this is going to require a whole lot of writing code. We've also got scale options in Azure SQL DB. We can size up. There's lots of sizings available for DTU based, or we can just add more vCores. We can go with elastic pools. Those are going to give us a lot of the same options. We can shard our environment by scaling it out, that way, or we can use our readable secondaries that are available through data movement, and we can scale out that way and scale our database up at least to some extent. But it's not always a great way to scale things up. A much better option is to scale things out. There's lots of ways to do that, because in Azure, there's lots of ways to do pretty much everything. Now, this is the kind of a great map here, and it just kind of shows a lot about all the options in Azure. So I'm just going to highlight our data part of it, because that's all we really care about here at SQL Saturday. And so one of the things I want to talk about is the fact that there are lots of ways to do everything in Azure. There's lots of ways to scale data sideways. There's lots of ways to scale data up. There's lots of ways to store data. And part of this is going to require picking the right environment to store your data so you can scale the right way. Great story I have on picking the wrong data solution. Something I found when I was talking to somebody on Facebook a few months ago now. So she worked for some company, I have no idea where, and they were building some API-driven thing that was going to give some sort of data to end users. I don't know what. But they built this whole process through a consulting firm, and that consulting firm had told them to use what's now known as Synapse Analytics, what was known as Azure SQL DB. So the consultants told them, we'll use Synapse because it will scale out really wide, and you can just tell it, you run a DW 4000, you can throw a ton of horsepower at it, and it'll be really wide, it'll support a ton of cores, you can do a ton of work with it. And, okay, cool. So that was how they built the whole thing out. And it worked really, really well for them until they started doing some load testing on it. Thank God they did load testing on it. because what they ended up finding was that it would tip over, and they could only run a couple hundred concurrent users before they had a problem, and things would start queuing. Now, the big problem with this was they needed to be able to support something like 10,000 concurrent transactions. So falling over a couple hundred was a problem. So she was posting on Facebook as to, hey, why am I seeing this problem? Why is this thing falling over as just a couple hundred users? So I'm like, well, you're using Synapse. Synapse only supports 128 concurrent transactions or concurrent queries. So if you're going beyond that, it's not going to work for you. So like script it all out, export your data, recreate your schema in a SQL database, just scale it up to a high size, throw your data in it, and at least start there, and that'll at least get you up and running, relatively quickly. You've done the hard work. You've done the schema design. You've done the application integration. So just move it over to SQL database. She's like, yep, no, this works perfectly. Now we can support, tens of thousands of users. I'm like, okay, cool. Eventually, this is going to hit bottlenecks as well. So you're going to need a way to scale things out, and you're going to need to look at caching some of your data and moving it from SQL DB and throwing it in something like Redis, so you can do some caching of your information. So, in the short term, SQL DB, good enough. Just slide right and go with a big size. Eventually, though, you're going to probably want to scale that down so you're spending less money and throw something like Redis in front of this so you can cache some of your data so that you're not making calls to that SQL database for the same information over and over and over again. You want to save some of that information in Redis if you can. Or you might need to move the whole process over to Cosmos. Cosmos is great because you can actually scale that out across multiple environments around the world, and it'll handle all this replication for you. Now, SQL DB is great because it will let you do a lot of that scaling as well, but you can only scale to 4 additional copies, for a total of 5 copies. So you might need more copies than that depending on your application and how it's built. So with Cosmos, you can literally put a copy of your data in every single data center around the world. The great thing about Cosmos is it's multi-write. So you can have writes going to all the different copies, and it will take care of syncing up all that data for you as that data moves around the world. And you can have really high rates of data processing all happening within your Cosmos DB environment. So it's a great way to actually be able to scale your data. Now, the downside to that is going to be the cost. Cosmos DB could end up being a very, very expensive solution because of the way Cosmos is priced. Cosmos pricing is based on the amount of data that you pull out every single time you run a query. So it can get very, very expensive if you're writing really poorly written queries against it, because things like table scans or loading the entire data set up into your application can suddenly get extremely expensive versus just running things within a SQL database or within a Redis cache or even a Synapse database. So you have to be very careful about how you're running things and where you're running things. Otherwise, things are going to get very, very pricey for you very, very fast.
Hi, Denny. Sorry to interrupt. Yeah, we have 5 minutes remaining. Yeah, 7
Cool.
minutes. Thanks.
Cool. Thank you. So one of the other great things you can do if you're not looking at Cosmos, if Cosmos isn't a great solution for you, then you can actually build active databases within SQL DB. It's just going to take a little bit of work because this is all going to be custom written code that's going to be handled through a queuing process, a queuing mechanism, where database changes aren't written to the database directly. They're going to be thrown to a queue. And in that queue, we then go ahead and write that data out to the various databases within the environment. So it's a really great solution, but it requires a lot of code to be actually written to do this data modification. Basically, all your writes are going to go to a central location, to a central queue. That queue will then forward that information out to all the various sub queues, one for each one for each location you're writing data to, and then something will then pick up all this data and all that data and throw it down into the actual database so that users can query that data. This requires the application to be built differently than a normal application, where normal applications assume the data is there. Here we use an eventually consistent model, and we assume the data is not there, but it'll get there eventually. So the data we're looking at now might not be the data that we need to look at going forward. So some things that will limit scalability in the long term is going to depend on what kind of application we have. If we've got a stateful application, we're probably going to have a memory problem that we need to address first. If we've got a synchronous application, an application that sends calls synchronously between various places, we're probably going to end up with a CPU problem. If we've got storage bottlenecks, we're probably going to have some disk issues because disk is storage. And if we've got applications with communications latency issues, that's going to be network link issues, network problems. And those are the hardest problems to solve, because that's what I like to call the speed of light problem. Because we have to move data from point A to point B. We can only do that so fast. So the big thing as an Azure admin, when I look at the application and I look at the environment that I'm working on, I go, okay, what are the problems that we're trying to solve? Okay, well, it's a stateful app. We're having all these memory issues. Okay, well, let's try to figure out what we need in the application to actually do that, and let's try to scale that application around that so we no longer have these sorts of problems. Now, I know I talked about a lot of stuff very, very quickly. If you do have any comments, please do make sure to put them in the chat. There should be a hands up feature, I believe, if you can click on that, and my good friend here will go ahead and unmute you and ask your question away. So do we have anything on the queue?
Yeah, there is a one question. Not why this? Why this? Actually, it's not a question, I think. Okay, Denny, I have one question for you.
Yeah.
Basically, for what would be the best practice for for the open source database to ensure the data encryption, for the open source in Microsoft Azure, like MySQL or what we are taking, like
MySQL, Postgres, MariaDB, those sorts of things. So if you're using, are you talking about the platform as a service side or the infrastructure as a service?
platform as a service size. Yeah.
Platform as a service. Okay, so MariaDB, MySQL, and PostgreSDB, they all have platform as a service offerings. So with all of those offerings, you can actually use TDE as part of it. Okay. So they can all encrypt their data through TDE, just like SQL Server can. It takes a little bit more work than SQL Server, because when doing it in traditional SQL DB, it's literally a matter of checking a checkbox and flipping on. So the other providers, they all have that. They all require a little bit more work to do it. There's information in docs.microsoft.com on how to actually do that and how to set up their version of TDE for their various databases, but it can be done with all three of those offerings.
Oh, okay. Thanks. Yeah.
So what we've covered today: security in Azure, availability in Azure, scalability in Azure. Unfortunately, I did skip a bunch of slides, but like I said, all the slides are uploaded to the SQL Saturday website. So hopefully you were able to use those slides and see what's going on. Feel free to shoot me an email if you have any questions, denny@dcac.com. If you'd like us to take a look at your Azure environment, obviously sales pitch time, hit us up, info@dcac.com, or check out our website. We'd be more than happy to help you with that. But other than that, thank you very much for having me. I do appreciate it. I believe Dinesh is up next. And have a great rest of your Saturday. I'm going to go watch some TV because it's currently 7:30 on Friday night.
Thanks, Denny. Have a nice weekend. So yeah, hi guys. Please provide a feedback for the session because there will be lucky draw at the end of the webinar.